Dang it. Hi, today we're going to be creating the game Snake in C++. Okay, so right here we have an empty C++ project. And this is the project that we're going to be creating Snake in. So, for this you need to have the SFML module for C++. And this is a really huge module that you can do a lot of stuff with. But for now we're just going to be using the graphics.hpp part of it. So the command you write at the top is #include sfmlgraphics/hpp. And you have to install that first, but that's really complicated, so I might show how to do that in a future video. So I'm just going to assume that you already have this installed. Now, so here's our main functions, which is int main. Alright, now, we're going to set up a canvas in SFML, so SF render window. And we're just going to call it window. So SF video mode. And we want this to be 700 by 700, so that means the canvas is going to be 700 pixels by 700 pixels. And then we want to call the canvas Snake. So at the top of the window, it'll just say Snake as a title. Right. Now, while window dot is open, so that this is going to be a while loop that is basically our loop that shows everything that happens in the game. So inputs, the snake moving, the snake growing, the apple moving, everything happens within this loop. So first we have to make sure that if someone wants to close the canvas, it closes. So SF event, and we'll just call it events. Okay, and while window dot pull event, so pull event. And what this is going to do is anything that goes within this loop here will happen if an event happens, like the user touches the mouse or touches a key or moves the mouse, and then it looks for the type of the event. So what happens? So if event dot type equals SF event closed. So if the event is the user closing the window, in that case, close the window. So window dot close. Alright, so what it does is it waits for the user to do something, and if what the user is doing is closing the window, then the window will close. So that's what we want to happen. And then window dot display and window dot clear. So what this does is if the window has not been closed yet, then it will display whatever is on the screen, which so far it's nothing, but once there is stuff, this command will display it. And then every frame we want to clear the screen, so stuff from previous frames doesn't get carried over to the next frame. So this window.clear command erases everything from the screen. So now if we run this, okay, so we have this this empty canvas right here, and you can see that the title is Snake, and it's just a black empty canvas, and it's a square canvas because we made it so it's 700 pixels by 700 pixels. And so far there's nothing on the canvas because nothing's happening, but everything works, so that's good. Okay, now there needs to be a snake on the screen, because in the game Snake, there's a snake on the screen. So we're going to make two arrays for the coordinates of the units of the snake. So we're going to call one of them square x's, and the other one's going to be called square y's. And they're going to be float, because it's numbers. I can't spell float right. And we're going to make this array 1000 1,225 units long. And the reason why I want it to be 1,225 units long is because this canvas is 700 pixels by 700 pixels. And I want the squares of the snake to be 20 pixels by 20 pixels. And that means that each square is 20 pixels by 20 pixels. So the canvas is going to be 35 squares long and 35 squares wide. And 35 times 35 is 1,225. So the snake can at maximum be 1,225 units long. So we don't need to have an array that's any longer than that. So this is the maximum length the array will have to be. So the starting coordinates of the snake are going to be 17, 18, 19. And I said that this field is 35 by 35, so 17, 18, 19 is going to be close to the middle. And then we need to make it for square-wise, so square-wise, and same thing as 125. And that's equal to, and we want them all to be on the same row, so 20, 20, 20. So now the snake is going to be in the middle of the map, about facing left to right, and it's 3 units long. And now we need to have an integer to represent the length of it, so length, and we're gonna have it 3, because it starts out being 3 long. Now what we need to do is make a system to draw these squares onto the screen. So we're gonna make a for loop. Int I equals 0, and then I is less than 3, or length, because the length of the snake is going to change throughout the game. So we're going to have it as I is less than length, and then I++, so it goes 0, 1, 2, and then in this it's going to find the square x's coordinate and the square y's coordinate. There also has to be an array of rectangles for the canvas. So SF rectangle shape. This is going to be an array of rectangle shape, and we're going to call it squares. And this is also going to be 1,225 units long. Alright, so now what it needs to do is go to squares, index I, and it's going to set it to SF rectangle shape of SF vector 2F, and then 20 by 20, because I said this is going to be 20 pixels by 20 pixels. So it creates a rectangle for each unit in the snake. Then it needs to set its fill color to green, so squares index I dot set fill color, and it's going to set it to SF color green. And then it needs to set its position, so squares I dot set position, and it's going to be another vector 2, so SF vector 2F, because it's a float, and square x's index I, square y's index I, because it needs to find the x coordinate and the y coordinate and then move the square to that coordinate. And then we're going to multiply that by 20, because each square is 20 pixels long, so, and 20 pixels wide, so it needs to multiply it by 20 so it moves it to the right place. Okay? And then we need to make an outline around the squares. So squares I dot set outline thickness. Let me see if I can spell that right. Outline thickness, and it's going to be 1.0. And then squares I. Then we have to set the color. So dot set outline color to SF color blue. So now what we have here is a loop that goes over these lists, and it's going to create a square that is 20 pixels wide, 20 pixels long, is green, is in the coordinates of its index in square x's and square y's, has an outline that's 1 pixel thick, and is the color blue. And then we have to actually draw it. So window dot draw, and then squares I. Alright, so that should work. There's obviously gonna be bugs, because there's always bugs. But let's see if there's any bugs. No bugs yet. Let's see. I have my fingers crossed, hoping that there's no bugs. It's taking a long time to load. It's taking forever to load. Hey, it actually works. See, so there's a snake. There's 3 squares, and each square has a blue outline, and it's green. And they're all in a line, just like I expected. So, yay, that works. Okay, so now the snake has to actually move. So, we're going to make a variable, and we're going to call it direction, or just dir for short, or dir. So, int dir is equal to 2. And the way this direction variable is going to work is it's going to be like clockwise. So 1 means up, 2 means right, 3 means down, and then 4 means left. So we need the player to be able to control this direction variable with the keyboard. So let's start with if SF keyboard, and then is key pressed. SF keyboard is key pressed, and then SF keyboard left. So if the player presses the left key, if he presses the left key, then we want direction to be 2, because that's 2 means left, so dir equals 2. But what you also have to remember is when you're controlling the snake, if it's going left, you don't want it to suddenly turn around and go right, because then it would just hit itself. So we want it to be able to go left unless it's already going right. If it's going right, then we can't let it turn around and be left. So right is 4, so if direction is not equal to 4, then we can do direction equals 2. Otherwise, nothing happens, because we don't want to be able to turn around and hit ourselves. I mean, eventually you do hit yourself when you're playing Snake, but not by turning 180 degrees and hitting your own neck. So, this works, but only for left. So I'm going to copy this if thing and just paste it 3 times. So now we have one for each direction. So the other one is right. And right is 4, so if we're not going left, then we can go right. So if direction is not equal to 2, then direction equals 4. And now let's do up. Now up is 1, so direction equals 1. And we can go up if we're not going down, so direction is not equal to 3. And then for down, it's the opposite. It's if direction is not equal to 1, then direction is equal to 3. And that should work if I run this. And looks like there's errors. Left cannot be used as a function, so hold on. I think I have my parentheses wrong. Oh yeah, because these parentheses are not supposed to be there. Yeah, that happens a lot when you're programming. You just have bugs that were never there before, but they are now. because you didn't expect them. Okay, the console's up. Loading. 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 Okay, and now if I press a bunch of arrow keys, I don't get a ton of error messages, which means the computer's not getting confused, but I don't know if the direction is changing in the way I want it to. So what I'm going to do is I'm going to say hashtag include IOStream. IOStream is what it does is it takes inputs from the console and then gives outputs to the console. And then at the very bottom, after every frame, I'm going to write standard cout direction. Also add end line. Oh, it's standard end line. Okay, so now I'm going to let that load. Wait for it to load. Now it's going to constantly output to the console the direction. So right now it's 2 because it defaults to 2. If I hit down, it turns to 3. Okay, so for some reason when I hold down 3, it goes back to 2. I think I know why that works. Because it defaults direction to 2 every frame. So really, this should be up here. And actually, all of this should be up here. I just realized that all of this has to be up here. I've been doing this wrong the whole time. That's okay, because that happens a lot when you're programming. You do something wrong that you didn't realize was wrong. Okay, so now it should work. Okay, so it's 2. I press down, it turns to 3. Press left, it becomes 4. No, 2. No, left is 2. Okay, down is 3. Up is 1. But for some reason right is 4 and left is 2. Oh, right, because I said it that way. But no, it's not supposed to be that way. It's supposed to default to 2. Right is supposed to be 2. Okay, so I got this backwards. So 4, 2, and then 4, 2. Yeah, I'd set right as number 2, but right was really supposed to be... No, right is supposed to be 2. I set left as 2. Right is supposed to be 2. Left is supposed to be 4. Alright. Let's run this again. Now it should work. Alright, so right is 2. Down is 3. Left is 4. Up is 1. And if it's going up and I press down, nothing changes. If it's going right and I press left, nothing changes. If it's going left and I press right, nothing changes. If I'm pressing down and I press up, nothing happens. Good. So that's working. And I'm going to have to wrap it up for this video because this is going to be a 2-part series. And this video is going to get super long anyway. So I'll finish making this in the next video. So until then, good